Declarative programming isn't a hot topic without reason. It increases readability, complexity, maintainability, code reusability, debugging, and many tools rely on it like SQL, HTML, and even programming styles like functional programming. So what is declarative programming? Declarative programming is all about what you want to achieve rather than how to do it. Unlike imperative programming, where you explicitly define the steps to reach a result, declarative programming allows you to express logic without detailing the control flow. Let's talk about a classical example: how to make a sandwich. In an imperative way, you would say, to make the sandwich, first spread the mayonnaise on a slice of bread, then add a lettuce, tomato, and a turkey, and finally place another slice of bread on top of it. The declarative way to make the sandwich would be, create a sandwich with mayonnaise, lettuce, tomato, turkey, and 2 slices of bread. So let's take the example retrieving data from a database in GIS and SQL. In GIS, you would just get employees from a database and create a results array. Now you iterate over the employees array, and if the employee is in the department in sales and his salary is over 50,000, you will push this employee into the results table. After you're finished, you just console log the result. In SQL, the more declarative way, you would say select name and email from the employees table, where department is sales and salary is over 50,000. You probably can see that the SQL approach, the more declarative approach, is far more readable and maintainable and can be read by pretty much everyone. So now let's look how you would filter an array in an imperative style. First, you create an array from 1 to 6, and then another array where we want to store our even numbers. Now we iterate over the numbers array and check if the number is even or not. If the number is even, we just push the number into the evens array. After we are finished, we console log the evens array. You probably noticed that you need a few seconds to read the code, but in the declarative way, it's far more easier to read. Like in the imperative way, we just create a numbers array from 1 to 6, and then we use the inbuilt function filter. The filter function takes a predicate as an argument. A predicate is just a function that checks if the argument fulfills the condition. Like you can see, we just pass in this predicate and check if the number is even or not. And after that, we get a result of all the even numbers in the array. And after that, we just log it to the console. You probably see that this code is far more readable and you can pretty much see everything you need in just one line of code. This is the power of declarative programming. So now let's look at another example. So now let's transform data in an imperative style. So now let's take the users array as an example. It exists out of 3 objects with an ID and a name. Now let's also create the names array where we want to store all the names. Now we need to iterate over the users array and push the name to the names array. And after that, we console log. Like you can see, it's not very complex, but it can be made far more readable in a declarative way. We also have the users array, but now instead of iterating over it, we just use the map function. The map function, instead of taking a predicate as its argument, is taking a callback function. A callback function just transforms the argument into another value. So if you have a math background, it's pretty much just a function. It transforms one data type into the other. So we transform the user data type, the user object, into a string. And after that, the map function returns all the names. And after we are finished with that, we just console log again. Like you can see again, this way is far more readable. And even if these are small examples where the true potential of declarative programming doesn't shine as much, if your code gets more complex, declarative programming can really help you to keep everything under control and readable. So now let's take a look about the reduce function. First, we create a card array that has objects inside of it with an ID, name, and price. And now we want to calculate the total price. And this is a very good example of the reduce function. The reduce function is very powerful and tries to reduce the input into one output. Like map and filter, reduce also takes a function as its argument. But unlike the others, it has two arguments, sum and product in this example. Sum just stands for the accumulating value that you want to add to, and product just stands for the current product that you add. And now we just write in our expression sum plus product dot price, and this accumulates all the prices in the array. And our second argument after our error function is just the initial value that we want to start with. In this case, it's 0, and now we can console log our total price. Like you can see, this is a very powerful function and can be used in many different ways, not just to calculate the total price or add numbers together. We can also reduce strings to one big string together, and far more many things. The reduce function is a very powerful function. So now let's talk about how to find a specific value in an array. The find function also takes a predicate as its argument. So it's pretty similar to the filter function, but instead of filtering all the elements, it just finds one value where the expression is true. In this case, we just say user ID is equal to 2. And after that, we just console log user. So now let's talk about the every and sum functions. The every function just means if every element in the array fulfills this predicate, then return true. And the sum function just means if some elements in the array fulfill this predicate, return true. They are very useful if you want to know if every element or some elements fulfill the predicate. In this case, both of them return false, because not all of them are below 500 and none of them are above 1000. They're very useful if you want to know if every or some elements fulfill the predicate. React and RxJS use declarative programming very intensively. Declarative programming in React focuses on describing what the UI should look like rather than how to manipulate the DOM to achieve that look. This approach contrasts with imperative programming, where you explicitly specify the steps needed to achieve a result. In React, you declare a structure of a UI using components which are functions or classes that return JSX, a syntax extension for JavaScript that looks similar to HTML. React takes care of rendering the UI and updating it when your underlying data changes. Here's a simple example of declarative programming in React. The useState function or hook code in React is used to manage the state of the count variable. The state is declared with an initial value of 0 and provides a function setCount to update it. The return statement in the counter component describes what the UI should look like based on the state. The JSX syntax is declarative ways to define the structure and appearance of the UI. The onClick events on the buttons are declaratively defined. When the button is clicked, the state is updated using the setCount function. React handles the re-rendering of the UI based on the new state. The component re-renders whenever the state changes, and React handles the necessary updates to the DOM efficiently. The developer doesn't need to manually update the UI or manage the DOM elements explicitly. This example demonstrates how React's declarative approach simplifies the development processing. I've only covered the basics today, and there's much more to learn, like declarative state management, how to write promise and async await in a declarative way, and there are still many more functions like for each that is very important, with, and many more. I hope this video has inspired you to learn more about declarative programming, because we only scratched the surface today. There are far more resources that go more depth than me, but I hope I could give you a grasp understanding what declarative programming is.